I'd like to introduce our next speaker before we come to the first break. It's actually my highly valued colleague Kurt Stockinger. He's the biggest expert in big data technology that I know. He's as well our highly valued director of studies of our data science course. And he also is a very active researcher. When I look at his desk and see all the proposals that are lying there and all the projects already running, I'm always amazed at how productive he is. And today we get a talk on an interdisciplinary approach on data science that we are focusing at here at ZHAW, and I'm very much looking forward to it. Kurt, thank you very much that you're here. Your stage.
Thank you for the introduction, Tilo. So what I will tell you today is what we're doing in the data lab, the ZHAW Datalab in German. It always sounds a bit, ZHAW is easier to pronounce than ZHAW, so excuse if I use the German word for it. And I tell you what we do in the data lab, both in terms of research, but also in terms of education. The talk shall give you an idea of what kind of activities we're doing, and maybe, since Tilo introduced you already, that you should chat with each other and connect. Maybe you also get some ideas of how you can actually work with us and solve interesting problems that are not only theoretically relevant, but also that are interesting for your business, how you can make new innovations and maybe keep the Swiss innovation level as high as it is and maybe even increase it at some point. So, what is the content of the talk? In the beginning I give you a little overview of what is our ZHAW Datalab, what we're doing. Then I tell you a little bit about what we're doing in terms of education, data science education. As you all know, these data scientists are considered the new heroes of the 21st century. Everyone wants to be one. We heard 70 of you are already. We make sure that also the other 110 that are here today maybe become data scientists one day. Then I give you an overview of 3 different applied research projects that we have done mainly with industry partners. They're from completely different areas. The first one is market monitoring, and there you basically have the problem of data warehousing combined with machine learning. The next one is sentiment analysis. So data sets are completely different. You have documents, and you want to figure out whether the documents talk positively or negatively about it, and you will see how this actually is done. And the third one is, again, a complete different direction. It's face recognition, how you can maybe find out which person is sitting in the room and to identify which person this is. So you see, very diverse problems, and I hope that after the talk you get a little bit of information of how this actually works, and maybe some ideas of how you might implement it yourself, and even better, maybe with us. Good. Maybe one background slide about the Zurich University of Applied Sciences. It's actually a pretty old institution, part of it. The School of Engineering has been around since 1874. It was then called the Technikum in Winterthur, and it's still highly appreciated. Then in 2009, something happened. 8 University of Applied Sciences in the canton of Zurich actually merged together to form the Zurich University of Applied Sciences, which also made a shift in the direction of the university. Before, in the Technikum, it was more like a teaching approach, and now, from maybe 2009, a little bit earlier, it's also research, applied research, and working directly with industry. This is when it became interesting for me, because in the past I worked at CERN, I worked at US labs, and I worked in applied research, and when I came here and I heard the university is really doing teaching plus applied research and working with industry, I thought that's cool. That's the place where I want to be. We have about 11,000 students that we're teaching every year and sending out to the market, and hopefully these guys make impact, and we're doing especially applied research projects. We have a pretty famous lecturer that we're very proud of it. Who do you think it could have been? It's already a little bit in the past. Mr. Einstein, he was here in 1901, so he was studying at Technikum, was there 6 months, was a great guy, but maybe the levels then were too high, so unfortunately 6 months afterwards he had to leave. Not maybe he was not smart enough, but he didn't fulfill some legal requirements. We missed him and he moved on to Bern, and 4 years later, he came up with his great theory, and Winterthur missed maybe some opportunity. Hope this doesn't happen. Now we're trying to catch up on this opportunity. And as you have seen with Tilo and our team, we've built up a data lab, data science laboratory. We're lucky that we were the early movers. We were one of the first ones in Europe to actually build such a data science laboratory. And what I personally find extremely exciting, we're not doing just computer science. My background is in computer science, database research. This is what I love, this is what I dream about. But what is really interesting in this lab, we're having a bunch of different teams there. So we have statisticians, applied mathematicians, physicists, and there you can really solve problems that are not just theoretical, but you can actually apply them also to industry. As the director already said, or our president from the university, we have 5 different institutes that are part of it. The first one is the Institute of Applied Information Technology. That's why I'm in there. It's basically the computer scientists. Then we have data analysis and process design. You can think of them, these are the applied statisticians. Then we have, and that's also important because we can do great things with data and we can do many things. The question is, are we allowed to do this? Is it ethical? So that's why we also have social law in there. So these guys will tell us a little bit, yeah, maybe you shouldn't do this, or you can even do more, because what I see in Central Europe, when it comes to big data or data science, first thing is, no, we shouldn't do it, it's all bad. But I think we could do more things if we actually anonymize the data and so on, so we can also do more things and not just sit back. So that's good that we have some legal barometer here. And then we have 2 other institutes, applied mathematics and physics and simulation. These 2 new institutes joined recently, and it's good to have an even bigger bunch of people looking at problems from a different side. Just take a little sip here. So that you actually also know, and what is important, we have about, the whole lab consists of about 60 associates. So you can see this is quite nice when an industry partner comes to us and says, yeah, we have this problem. We can think, okay, we maybe need some database guys, we maybe need some machine learning guys, and we take maybe some applied statisticians. We look into these institutes, pick the people, build a team, and then we can solve problems in this way. And this is, I find this very interesting, very challenging, because not every person knows all the problems. As I said, I'm a database researcher. I would not know the details about machine learning, but therefore we have our machine learning experts in this area. Who are the people? You can see the faces here, so if you look around, you might recognize some of them. Tilo is heading this whole activity. I think this is good that we got it all started. Oliver is sitting here in the first row. Maybe you want to... He's also session chair for the interactive track. And then the other people are also here. You can see with the names and the numbers to which institutes they actually belong to. And you see it's pretty diverse. Now that I've told you a little bit about the lab and you know about the people, let's go a little bit in what we're actually doing. And we will start with the education. We start with our data science education. So this is a professional education, also sometimes called continuing education. This is kind of a postgraduate education. So you have already maybe some background, you have studied computer science or you have studied economics or whatever, and you want to know a bit more about data science. So there we have developed this Diploma of Advanced Studies. And here we have to say we were early movers. We were lucky that our universities allowed us to move so quickly. The whole studies consist of 3 parts. And one of them is the information engineering part. So this is more the computer science stuff, where you learn about information retrieval, text analysis, how to find out whether something is positive or negative, and also data warehousing and big data. The next part is data analysis, so this is more the statistical backgrounds, what is regression analysis, what is clustering, if you want to figure out. You have some group of customers that are behaving in some way, and then you have a potential new customer, and you want to figure out what kind of product do you want to offer to this person. If you figure out that some of the behavior is similar to some other persons that you know already, you can kind of predict what this person might want and offer them the good product. So this you might learn also in this course. And then when you have done the computer science background and the statistics background, You can then do data science applications. This basically puts everything together. Then you do machine learning, even more statistics, visualization, and so on. Plus, there's also some part of data protection, so to see whether it's ethically correct, whether you do it, or whether it's actually in the legal boundaries and so on, and also a little bit of data security, because you want to make sure that the data that is out there is actually encrypted and safe. How can you study this? There's two ways. It's a pretty flexible way. You can study it actually in 1 year, then you can do 2 of these certificate of advanced studies in parallel, and the third one in the end. Or if you want to take a bit more time, you can do it in 2 years, and then you're done. I'm happy that there's some of our students actually in here, so if you want to know how this is actually working, I see one here, and I see another one here, and I think even here in the first row, so yeah, I see 4, maybe even more. So they can tell, or even the 5th one here. If you want to know, and the 6th one, right? These guys will tell you. From me, of course, you only hear the good stories. From them, you hear how it's really working. So don't tell too many bad things. So now we have told you about the education. I hope I got you a little bit interested. And now I show you, with this education, you can solve these kind of problems. And we start with the market monitoring project. This market monitoring is, we're doing it together with a Swiss startup company. I can't tell the name because we have a non-disclosure agreement with them, since they're pretty early movers in the market and they don't want to give away their names so that others are doing something similar. What it basically is, it's an e-commerce platform, and in this e-commerce platform you have tens of millions of products and tens of millions of users actually using it. They focus on cosmetics and groceries, and the idea is that users can go to this web page or to this portal and get information about healthy products, and that are maybe also produced with sustainable production, so that you don't use maybe parts from the Amazon forest or whatever, so that you basically look there, find out what are good products and what don't harm the environment. And the idea is, what we're doing, we want to recommend these people when they are surfing this web page, what are good products for them, and recommend them better ones. Now you might think, okay, the problem looks very similar to Amazon or Netflix. They have been doing this for many years. Why is this a hard problem? The main difference is, and this, I think these are nice differences, all the users are anonymous, so that you don't need to log on to this web page, so you don't keep a footpath or a footprint, and there's no buying required. So this means these are 2 fundamental different assumptions to solving the problem than Amazon and Netflix have. When you buy a book, it recommends you 3 other books. So that's why solving this problem is quite different, and maybe even a harder problem, because you have just less information. I give you a little insight of how we actually have solved it. So what you can see on the left side, this is the product DB, the database. And this is where you have the information about the users, about the products that are actually out there. What is also interesting, it's not that these are not nicely curated by some machine and then the products are entered, but the users enter the products themselves. So this means this is like a crowdsourcing approach. You can actually use this at some point, enter the products yourself if it's not there, and then it's in the database. Now we said we have tens of millions of these. We need to take these ones and put them into a warehouse, because you cannot just take the product database and analyze it and find out nice patterns, but you first put them into a warehouse. There you typically have what is called a staging area, basically take a one-to-one copy of the database. Then the next part, and this is the most difficult part, you need to integrate the data, clean it up, reduce the redundancies and so on. And for those of you who are in data warehousing or in database in general, data integration is one of the toughest problems in database. Why? Because you have to find out whether things are similar, whether they are duplicates and so on. Machines are not very good at this, so therefore you need a lot of human interaction. So integrating this is a tough problem. It takes some time. You need to figure out the quality. People don't really like to do this. They think, I have my data, I can immediately start machine learning and get great results. Unfortunately, that's not the case. Therefore, in order to do real serious analysis, most probably you need to do this integration step, clean the data up and so on. Only afterwards can you then do some enrichment and actually do your analysis. In terms of technology, since we're working here with a startup, they don't want to buy the big expensive tools. We use completely open source technology. As a database is MariaDB. Some of you might know MySQL since it was bought by Oracle. It's now MariaDB is really the open source part. And as an ETL tool, so the integration we use Pentao, also open source. So once we have the warehouse and we have everything integrated, which takes quite some time, and not only for us, it's in general, data warehousing is a long task, it's a tedious task, but it pays off. So once you have it integrated, you can really look for the cool stuff. You can do some machine learning or data mining on it. So what we see here is we want to figure out which products are similar when users are going through the web pages and looking at products. So here on the left side, you see some click path. This is when you go from one product to another one, you leave a trace. In our case, we don't know who the users are. It's completely anonymous. But what we know is which kind of products they actually looked at. Then we can formulate as kind of a graph problem. So all the products you can see here on a graph. You have basically then a matrix. When product A was actually looked at, maybe you look at B and C. And then you can use these distances and figure out what are the clusters and which kind of products are similar. And then when you figure this out, you can recommend them in this way. The algorithm that we have chosen here is DB-scan. So DB does not stand for database. It is for distance-based. And you can basically, it works simple in a way that you say, here's product A, here's product B, there's a distance of 3. And between product A and product C is a distance of 9. And then you use this function here, where you basically aggregate the click path and then you come up with some clusters. If you want to know more about this, the one who implemented this actually sits here. This is Melanie. This is the lady that you have seen at the reception. She's not just a receptionist, but she's our PhD student, and she's doing great stuff in actually building these models and doing this machine learning. Details you can ask her, and I'm sure she has great answers. So here's the picture. Nice, colorful picture of what kind of things you can find out with the clustering. So here you have, maybe let's take this purple, I like this color. You see here that specific makeup products fall into this cluster. In another cluster you have some products that are maybe from Mary Kay. I have no idea what this is, some kind of cosmetics things. But you can see already, you find nice clusters, you use this approach, and then when you figure out that some person is interested in this one, you can recommend similar one, and then add an additional function that you choose only those that are actually healthier or have better ingredients. This is one project. Another one is a sentiment analysis project, and this is done by Mark. He's also here. Maybe you can get up a bit. Mark is also leading the session, the session chair for the analytics track or the interactive track, so you will see him again. For details, I also refer to him, but I'll just give you the gist of what this actually is about. The idea is here that you have a bunch of documents and you want to figure out, are these people that are talking maybe on these documents or in this, are they talking positively or negatively about something? So if you have a company and you launch a product, you want to know, do people receive it well? Or are they just bashing about it and say it's complete rubbish and so on? Therefore you can use some sentiment analysis techniques. Sentiment analysis is part of text analysis. Another part of text analysis would be machine translation, and especially here in machine translation we have seen quite some advantages in the last 5 to 10 years because of some techniques that I will talk to you in a second. So now the question is, how do you do sentiment analysis? How do you figure out whether a text says something positive or negative? For us humans it's pretty easy because we understand the semantics, we even understand irony, we maybe understand sarcasm. For computers this is very difficult to understand. So therefore the approach is here, that is, say you have some bunch of documents, it can be information from forums, it can be blogs, it can be Twitter feeds or whatever, you name it. You add them to a collection, then you do some processing magic, then you do some analysis, and the output should then be very simple. Is it green? Do they say something positive about it? Is it red? Is it negative? Or is it somewhere in between? Then it might be neutral. The question is now, how do you solve this? How do you approach such a problem? You have basically two approaches. The one is the rule-based approach. This is where you say, I build a grammar, I understand the language, I maybe understand the semantics, build up a complicated model, which has been done quite successfully. These ways work quite well. So you have here, for instance, a sentence, Tom pushed the car. And then if you analyze it, you figure out what is a noun, car is maybe another noun, pushing is a verb, and so on. You find the adjectives, and then you can figure out, is it positive or negative? Works pretty well. It has one downside, and this is a very important downside. To understand the grammar is very difficult. You have to build rules, build many rules, and every natural language has many exceptions. So therefore, to do this, maybe it works for one language, but still you need to tweak quite a bit, you need to do many rules. It does not work for another language. So if you want to translate in another language or find it for a sentiment, you have to start from scratch. Maybe it's something that you don't want to do. Therefore, a corpus-based approach takes a completely different approach. It's independent from the domain language or from the domain. You don't need to understand the grammar. You don't need to understand what kind of languages it is, but you use a machine learning-based approach. And the ideas are simple. The actual implementation is actually harder. That you say, you train the system, you give a bunch of documents and say, or words, these are positive words. If good is in there, or excellent, or whatever, not so bad. These are all good words. You train it. Then you have a bunch of documents or words that are negative, like this is not really great, or this is whatever. And then the system learns what is good, what is bad, and then applying this knowledge to new documents or to new words, then you can figure out whether it's something positive or negative. Has a huge advantage. It suddenly doesn't work only for one language, but it works, if you do it well, it works for any language. And then you can figure this out much better. What has Mark and his team done? They've implemented several different systems. They've implemented, and it works pretty well, and you find the details actually outside. There's a booth where the Twitter streams are analyzed. You can look at it and actually see for yourself how well it works. So here's the link, you find it there on the booth. Last project that I want to talk about is face recognition. Here the contact is Oliver. As I said, he's the session chair for the interactive track. And, sorry? Deputy, okay, deputy. Good. The idea is here that you have a bunch of pictures and you want to figure out which persons are actually on there. And what they have done in their project, they used the deep learning approach, which is now the modern way of doing machine learning or neural networks. It's a multi-layer neural network. You have the images, and then you want to figure out what person is actually in there, what you see. So on top you have kind of a training set, and then below here you have a test set, so you apply the training. First step is you need to figure out, actually this is a figure, a face, you need to identify the face. Once you have identified, you can put it through the neural network or through the deep learning approach, which is a neural network with several layers. And then what comes out, kind of a probability, which person is it? So in this case, the probability is high that it's this person in between, and so on. I show you a little video to see actually how the whole thing really works. And I'm almost done. Here in this video you see pictures on top. First thing, recognize that this is a face. Then here it's one layer of the neural network identifies what's happened, then it's the next layer of the neural network, of the deep learning network. And what is the outcome? Then a probability that, here in this case it says, with 100% probability it's the ego. If we go a little further, then you can see, let's take Oliver. That's a good example here. Now the algorithm is not so sure, you have seen. It doesn't always identify the right person. It says some probabilities it's Oliver, some probability it's another person. How well does it work? So Oliver and his team have implemented this and they compared it to what's the best out there. And the best is usually this OpenCV. It's an open computer vision library. It's open source code for these kind of approaches. There are two algorithms in there that they have compared to. CNN is the convolutional neural network that they've implemented. And what we can see is, first of all, their accuracy, which is a measure for how well these algorithms work. Their deep learning approach has a higher accuracy, 99% accuracy as compared to the standard approach that you find in this library. And it's also a factor of 5 faster. So this approach takes about 500 seconds to solve this problem. Their approach takes about 100 seconds. So it's really a factor of 5. Good. I think I'm out of time. Wrapping up. I've given you some information about the projects that we're doing. What is really important, before you can start machine learning, often you have to maybe do a data warehousing approach, clean the data, only then can you do the nugging, or the digging for the gold nuggets, or look back. You cannot just start machine learning on an unintegrated approach. What is also important for solving these problems, you always need, or very often you need a very interdisciplinary team. And I'm happy that we have this at our ZHAW Datalab of different scientists. It's pretty attractive for industry. As we can see, people approach us, companies approach us, and we solve problems with them. And we also educate scientists of the future. That's it for now. Ready for questions and comments.
Thank you very much, Kurt, for that talk. Summarizing the research of 2 years and 60 people in 20 minutes is quite a challenge.